Power transmission and distribution starts with power generation. A power generation plant is a facility designed to produce electric energy from another form of energy, such as thermal, which includes fossil fuels, nuclear, geothermal, and solar thermal. Power generation can also come from hydroelectric, wind, and solar. In above-average water years, hydroelectric plants are typically the largest source of electricity in Idaho. Harnessing the power of water is what hydroelectric power plants are designed to do. In essence, the dam is a factory that converts the energy of falling water into the flow of electrons or electricity. Water at the higher level is collected into the forebay. It flows through the plant intake into a pipe called a penstock, which carries it down to a turbine water wheel at the lower water level. The water pressure increases as it flows down the penstock. It is this pressure and flow that drives the turbine that is connected to a generator. Inside the generator is the rotor that is spun by the turbine. Large electromagnets are attached to the rotor located within copper wires called the stator. As the generator rotor spins the magnets, a flow of electrons is created in the coils of the stator. The electron flow is sent to power station transformers that increase or step up voltage from the power plant to higher voltage transmission line levels for long-distance transmission of power. Alternating current is normally preferred, as its voltage may be easily stepped up by a transformer. This minimizes resistive loss in the conductors that are used to transmit power over great distances. Idaho Power's transmission system spans southern Idaho from eastern Oregon to western Wyoming. The system is composed of 115, 138, 161, 230, 345, and 500 kilovolt transmission facilities. The sets of lines that transmit power from one geographic area to another are known as transmission paths. These paths all feed into a main grid substation. The purpose of the substation is to convert the high voltage transmission to 46, 69, and 138 kilovolts for transmission to distribution substations. Customers, however, can't use electricity directly from high-voltage transmission lines because homes and businesses are not set up to handle hundreds of thousands of volts. Instead, the high-voltage electricity flows into transformers at the transmission substations, where the voltage is stepped down to between 4 and 34 kilovolts, which can be used by industrial customers, but it's still too high for residential use. The electricity from the transmission substations is stepped down once again to between 480 volts to 4 kilovolts. This occurs at distribution substations. Smaller distribution lines then bring electricity to homes and businesses. Transformers, frequently at the top of power poles, reduce the voltage again to 120 to 240 volts before it enters a home. Since electricity travels at the speed of light, 186,000 miles per second, it takes only a fraction of a second for it to get from where it's generated to where it's used. A customer in Pocatello can operate a vacuum cleaner on electricity produced less than a second earlier, hundreds of miles away in Hell's Canyon.